Unlike quadratics, quartic functions do not have one standard shape, and I've already done a graphing of the derivative from a function in a previous video of a quartic, which is very common. This time I want to go through another type of quartic function. This quartic function has a minima, and it will also have a stationary point of inflection. Graphing a derivative of this function needs to start by establishing where the maxima or the minima or the stationary points of inflections are. It is at these points that you'll find that the derivative is equal to 0, which means that the gradient or the slope is horizontal. Therefore, these points on our derivative function will be equal to 0. And by drawing a vertical line towards the derivative function, we can show you where the 0 points will be from the minimum and from the stationary points of inflection. And after you've drawn these points on the derivative function, you're going to highlight the parts of the function, original function, where the slope is positive or negative. And so the slope begins being negative on this side of the stationary point, and it's also negative after the stationary point all the way down to the minimum. And then this is followed by a positive slope. These highlights only help me to determine where the derivative function will be drawn. So if we have a negative slope, the derivative function will be shown below the x-axis over here. And so our derivative function here will be below the x-axis, whereas our derivative function here will lie above the x-axis. So where do we start? We know we have to get back to that 0 point over here, and we have to be underneath the x-axis, since the slope is the steepest at the top. And as the x increases, the x values which are here increase, the slope decreases up to 0. And I'll just show this as smaller values of negative, decreasing, 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 decreasing slope. Now we need to show this decrease in the slope function, and we need to show it below over here. So the very high values, negative values, will become the very low negative values here, which will decrease until they get to 0. But the slope of the function continues to be negative in this section over here as well. So, and it needs to come back to 0 at this point again. So what is happening with the slope here? It's obviously still negative and it's still quite small, but it keeps on increasing as we go along because it seems to increase. It increases to a particular point and then it starts to decrease again. So it gets to 0. And this point here, where it changes, is called the point of inflection. But it's not a stationary point of inflection such as the one we had here. This one is called the non-stationary inflection. And you'll note that at that non-stationary point of inflection, we will have a minimum. It is going to, the slope is the steepest at that point. So we must go down and then follow up again. And you can see that that point relates to this minimum over here. Now we need to show the positive slope. If you look at the positive slope, we start with a very gradual slope here, and this then starts to increase and it starts increasing and increasing even more. So we need to show a gradual slope of increase followed by a steeper slope. So it'll go like this. Well, this shows us the derivative of that function above, which was a quartic, and the derivative function is now a cubic function. And we now need to find the derivative of the cubic function. So we start from the beginning and we establish where are the maxima and the minima. There are no stationary points of inflection in here. There are just the maxima and the minima. The maxima would be here and the minima would be here. And now we get to draw another set of axes, and I'll draw a dotted line to show where that 0 will be from here, and also a dotted line from the minimum to show where the 0 will be over here. Between the maximum and the minimum you will find the non-stationary point of inflection, which will then turn into either a maxima or minima. Let's see. And so we highlight the positive parts. This is our positive slope, and this positive slope is shown also on the right hand side over here. And then we have a negative slope, which is shown here right in the middle. So I'm just going to highlight these. And now we can follow step 3 and 4, where the positive slope will be shown above the x-axis, and this is our positive slope. The gradient loses its steepness and becomes 0 again here. Now we need to go below the x-axis for the negative slope, but we need to make sure that it comes back to 0 over here. And you'll note that there is a point of inflection in the middle. This is a non-stationary inflection, and this non-stationary point of inflection will occur right down here. It'll become the minimum, and our derivative will continue underneath here, and then again it becomes positive, so we need to do it above the x-axis, and we continue on. The function that we looked at initially was a quartic. We found the derivative of it and it became the cubic function, denoted by f dash x. And now once we found the derivative of the cubic function, that's the slope of the cubic function, we drew it and it became a quadratic function, which has a typical shape of a parabola. Now that will be denoted by f double dash x. Now if we were to differentiate that once more, we would get a linear function. Let's just do one more axis. And if you remember all the steps, we first of all look for the maxima or the minima, and we've got the minima over here, so we draw that to the 0 point. Now I'm not going to be highlighting the positive and negative. There's only one negative section and one positive section, so we'll just use the rule 3 and 4. If it's negative, it's below the x-axis, and so we just draw a line below the x-axis and go to the 0 point and draw this above the x-axis, and that is a linear function, which will now be f triple x. Now this type of quartic function is very popular to be given in exams. It's sometimes inverted, sometimes it's reflected, but it's there with the stationary points of inflection and the minimum or a maximum. And there is one other quartic one that I want to show you. This is also very popular and very different. So if you could subscribe to this channel and also like it, especially if you found it useful and you're going to be looking forward to the next video.